Hello and welcome to this video. I will go over manual assembly of branch type instructions. If you remember, a branch instruction is an instruction that allows you to branch from a current location to another location. Sometimes we use labels to kind of branch to that label, and the CPU knows how far that instruction is. So an example of this is when we did the loop. We branch back to the beginning of the loop under certain condition, otherwise we do not. So the 32 bits for the instructions that are branch type are broken down into these 4 fields, right? So it is pretty straightforward, actually. The tricky part here is calculating the offset where that you need to branch to, like how many instructions you have to skip or how many instructions you have to go back to get to the destination. So those fields are the condition, which is similar to the condition field we covered in previous type of instructions, the data processing. Then you have a 101, that's always there, that's a hard-coded value of 101, followed by the L field, which is the link. If this instruction is a branch and link, then that field will be set to 1, meaning you are linking back to the next instruction on the return. If it's just a branch, then you just, or the CPU just branches back or branches to a label given. And then you have 24 bits of offset. And we, again, the straightforward part is the condition. We know how to do that. 101 is easy. And then the L, if you have a link or not. The tricky part here is actually figuring out how to do the offset, how to calculate the offset. So let's do an example and go over it. Yeah. So since the branch actually requires more than one instruction, I wrote down a few lines of instructions and I have a couple of branch instructions, and we'll do 1 or 2 in this case. So let's see, in this example here, I have this branch, I have this branch, and I have this branch. So I have 3 branch instructions, and we're going to hand assemble the first one and take it from there. So what I'm going to do actually is I'm going to remove all these values from here, right? And then kind of like do it with you guys. I'm gonna maybe put it here on the top, and then we'll do it. Let's do this, right? So now I have a field here that I can write with. So the condition here is EQ, and EQ is 0, 0, 0, 0. Then I have my 101. This is only a branch, there is no link, so the L value is, or the L field is 0. Now the offset is the difference between where I am right now and where I have to go to. So this is branching to break. Break is 1, 2, 3, 4, 5 instructions after the current instruction. Now, typically what I would do is I would just use the 24 bits to indicate the value of 5. So it would be 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And then here I would do my 5, right? But there's a small catch here, which is because of prefetching, I have to account for 2 instructions that are already in the pipeline of the CPU. So instead of jumping over 5, essentially I'm telling the CPU I need to jump over only 3 because I have to account for the prefetching in which the CPU is already ahead of the execution, so to say. So just remember this rule, I have to skip 2. So whatever number you have, if you count and you find you have to jump 9 spaces, make that a 7. If you need to branch backward 7 spaces, make that a 9 because you're already 2 steps ahead. So if you had to go back from here by 7, then it will be by 9. So instead of having a 5, I'm going to change that into a 3, and that's it. That's my my assembly value for the branch instruction, and that's good. So I'm going to remove this word from here, And then under this, I'm going to write this in hex. So this is a 0. And this is 1 0 1 0. That's an A. And then followed by 0 0 0 0 0 3. And that's it. If you write some code and you have two branches, or you have a branch instruction in which it will branch to a location that's 5 steps ahead, you will end up with 0A 0 0 0 0 0 3. Let's do another one. Let's do the second one. In this case, I have this branch instruction branching back into that loop label, or this instruction, the AND instruction. So essentially, I have to branch back 1 2 3 4 5 6 7. I have to go back 7 steps. But because of prefetching, I have to account for 2 more instructions that are already in the pipeline. So I have to jump back 9 instructions. Okay. So let's remove this code here and write it again. First of all, the condition is always, there is implicit AL, so that's 1110, followed by 101. It's not a link, there's no link, it's just a branch, it's B loop, so that's a 0. And now the offset, I'm just going to write here negative, it must be -9, but I have to express -9 in 2's complement, right? That's how we write negative values in binary. So how do I get to -9? Well, I start with 9 and then I flip the bit. So I'm going to, let me just do this. So 9 in binary is 1001. Okay, and I'm not going to write the 24 bits, but it's actually, let me do this. 1 2 3 4 5 6 16. Okay, so this is +9. Now, if you want to get the 2's complement of this to represent -9, what we do is we flip all these bits, right? Like that. And then add 1 to it, right? So if I add 1 to this number, I get this value of 1. So this number right here is my -9 in 2's complement. So I'm going to just remove it from there and type it here. So now if I write this in hex, I have my E. 1010 is an A, followed by F, 2, 3, 4, 5, 7. So that instruction will be EA, FF, FF, F7. And that's it. That's the branch instruction manual assembly. Thank you for watching, and I'll see you in the next video.